He's acting friendly. Looked her with a hat on
I
too.
know.
I
And
was
no
like,
glasses, yeah.
yeah. And then he walking down, I'm like, yeah.
Yeah.
How are you doing up there?
I was going to get coffee and I don't walk outside.
Going for a walk. There used to be.
Like maths on the fourth floor.
Oh, your office?
Yeah.
Are you a grad student?
Cool.
Are
Yeah.
you in
TA.
doing a master's of engineering?
Yeah.
We have a. There used to be a tunnel that went from here over to there.
Well,
Over to the gym.
Yeah, because the faculty locker rooms used to be over here, and then you go over there. Yeah, the faculty used to have locker rooms. They used to have locker room attendants, like students in there, like handing out towels and stuff. Like, isn't that interesting? It was before my time.
But if I
Before
want
my
to,
time.
if I want to go to Norm or to the sub for coffee, I can just go down Florida and across and then down to there.
my office is in that.
Yeah.
The room I walk into. All the stuff Mike doesn't understand.
Yeah, all the environmental.
Yeah.
Environmental biology, bacterial system.
Yeah. As soon as you guys start talking, I just plug my ears. It's like I don't want to know.
Why are you in my office?
The rocks.
80 forces meetings in Mike's office. But yes.
To make me go to him. To make me go to him.
Because he won't come.
I won't come to him, by the way. I won't come to him. That's a true statement.
Been to her office. Well, Flynn's is right next door, so you probably.
I've been up there, but yeah, I haven't gone. It's nice. It's more conducive to learning in her than mine.
You both have really nice office. Like, there's ambiance in your office.
Yeah, good.
Some
Yeah, yeah.
people
I got
on the
candles.
second floor, it's
Yeah, yeah.
like, these are sterile.
Yeah, I got candles
Might
in it.
have, like, lighting and
Yeah, that's right. I do
fun
go with.
things on the walls.
Yeah.
Do you have music playing sometimes?
Oh yeah, music playing, just hanging out where I can.
You're up at 300.
I was. It was great. It was great. It was great.
Thursday I'm gonna go up and I think it's still gonna be good.
Should be great. It was cold though. It was like -4 at
Supposed to get snow
the
every day.
-4 at the base, and then 15 at the top of Bridger. So 15, it was great up there, but you'd ski down into the cold, and then you'd feel it. All right, let's do this.
Are your toes cold?
No.
Never.
No.
I'm tough. So you just couldn't feel them.
No, I'm good. My wife gets cold. I was so worried. And I wear hand warmers.
I do that.
Yeah.
Eat your feet.
No, but we have toe warmers.
Pretty much every time I go skiing, it's below freezing. I've got hand warmers.
Yeah. Do you ever have the toe warmers that are like hand warmers that they stick to your socks?
I've never actually in your boots.
Yeah, my wife does
I've never
that. They're
done
really thin. They're made of the same material as your hand warmers, and they're sticky. So you put them on the top of your socks, and then you put your
I
foot in.
should try that.
Yeah, it's great.
My dad bought these for socks.
Yeah.
They have like
They're like
little battery packs.
$500.
I don't think he spent $500.
Yeah.
My dad, that's not something my dad would say. I don't know how much they got. I'll look it up. Awesome. But you control it from your phone and you can change the heat.
Yeah. I bet you paid $500 for those, or close to it.
Usually, like, I do a few runs. They get
All right,
cold,
let's do this.
warm up.
Last time we talked about rational operators, right? And that is, is it equal? Is it greater than? Is it less than? Stuff like that, and how it works. We did logical operators, right? Which is the ands and the ors and the exclusive ors and the nots, right? We talked about those. You include in your homework. And then we did the find command, and then you attempted this example, right? And then we're getting into if statements, which I don't think we didn't do if statements last time, right? We did do if statements.
We did.
We did that.
Oh yeah, and then you did this. Yep, you told that. And you did an if statement. Oh, two variables and return to the maximum. But we did not do switch statements.
No.
Right? It's switch statements are fine. I've rarely used switch statements because they're the same thing that a switch statement could do an if statement could do. Right? I mean, it's the same, right? You could imagine. So the way a switch statement is, you say switch x. So I'm doing a switch on the variable x. Case it's 1, case it's 2, case it's 3, case it's 4. So is it 1, is it 2, is it 3, is it 4? And so you could tell it to do each of those things. So case it's 1, it says display x equals 1. Case it's 2, just says display x equals 2. Case it's 3, display x equals 3. Otherwise, display x does not equal 1, 2, or 3. Okay, that's it. That's how this thing would work. Again, you could do this with an if statement, right? If x equals 1, display this. Else if x equals this, else if x equals this. So not all programming languages have switch statements because it's just another way of doing an if statement, but it does exist. Okay, I think your homework has you do a switch statement. Okay, for loops. This is where like the real power of MATLAB comes in, is these loops in general, because it prevents you from having to write the same thing over and over and over. Okay. The way that they work in MATLAB is you give it a vector, right? And we'll usually write it slightly different. Usually write the second way that we have down there. But usually you give it a vector. So in this case, A is equal to 1.1, 7.2, 6, and 2. So it's there's 4 elements here, 1.1, 7.2, 6, and 2. So that's what A equals that vector. It has 4 elements in it. And then I say for I equals A. So what it does is it runs through this loop, and the very first time through the loop, it sets I equal to the first thing in A. And so in this case, it'd be 1.1, right? And then it goes through, and then right here just displays I. So right now, it just says I equals to 1.1, because it just goes through, it sets it equal to the first thing, and then it displays it. So right here it says I is equal to 1.1. Then it comes around, the second loop around, it sets it equal to the second thing in that vector, which is 7.2, and then it displays it. So in this case, it just displays I is equal to 7.2, and then it does it one more time, or another time, and it says I equals 6, and it displays I equals 6, and then it goes through another time, and it shows I equal to 2. So that's fine. That's how it does it in general. You just give it a vector, and it says I equals that, and it runs through, and it sets I equal to each one of those elements and does things to it. Obviously, this is a silly example, right? The way I usually do it is like this. I usually say where I equals 1 to 4. I usually use the I as a counter, right? It says I'm going to go through it once, and then I'm going to go through it twice, and then I'm going to go 3 times and 4 times. But really, right, 1:4 makes a vector of 1, 2, 3, and 4. And so just to show you, that's what it's doing. It's going set to the first thing, second thing, third thing, fourth thing, right? So then if I do this one, I equals 1 to 4, it goes I equals 1, 2, 3, and 4. So it runs through that loop and displays what I equals each time you go through it, okay? I usually do my loops like this, right? So if I have I equals 1 to the length of some vector. So we'll do some examples, but I have I equals 1 to the length of something. So it's going to run through however many elements A has. Length of A is how many elements A has. And then right here I'm going to say A of I. This is indexing A, right? And so A is going to go through, or I is going to go through, it's going to be equal to 1, and it says what's A of 1? A of 1 is 1.1. Then it goes through again the second time and sets I equal to 2 and says what is I of 2? I of 2 is 7.2, and then it does 3 times and then the 4 times. So it just changes I each time, and then the way that this code right here is written, it just changes I and then indexes I and says what is your first, second, third, and fourth element, okay? And so here's a more advanced one right here. So it goes through and it says, all right, I is equal to 1 to 4. So it's going to run through this thing 4 times. First time through, it sets I equal to 1. So then it goes B of I, so B1, the very first element in B is going to be 4 to the first. Because in this case, I is equal to 1, right? I is equal to 1. So it goes B of 1 is equal to 4 to 1. And so right there, B is equal to 4, right? It's only one element. One thing that MATLAB lets you do that other coding languages don't do is B, if you can see here, B starts out as just being one element long, but then I'm going to run through it again and it's going to grow, and then I'm going to run through a third time and it's going to grow. So right now B is just one element, and I'm going to run it through a second time, so it goes through the second time, so B is equal to 1, I is equal to 1, now I is equal to 2. The second round through, I is equal to 2. B of 2 is equal to 4 to the second. Right? So B of 2 should be equal to 16. So B in this case right now is 4 for the first time through and 16 for the second time through. Okay? And then notice that it's 2 elements long. MATLAB lets you do it. MATLAB lets you make it, let it grow like that. Keep in mind, that's not the most efficient way to do it. It runs slower when you let it grow like that. If you pre-allocate space for it, it goes faster. Third time through, I is equal to 3, so it says B of 3 is equal to 4 to the third, which would be 64, and so it's 4, 16, and 64, and then the fourth time through, I is equal to 4, so B of 4 is equal to 4 to the fourth, which is 256, and so it just keeps growing like that, okay? That's a for loop, okay? You can nest them. You can nest your for loops, right? The things you gotta be, so this one says here, for I equal 1 to 2, display I loop number num to string 1. So this just displays which loop we're in, okay? Then inside of that for loop, it runs j equal 3 to 4 and then display j, okay? So it displays the jth element, and then it comes back and then does that for loop again. So the way it works first is it comes through is it set I equal to 1. So I is equal to 1, and then so right here it would say display I loop number 1 is what it'll say. And then it's inside here, and so it sets j equal to 3, and it displays 3, and then it goes through, and then j becomes 4 for the second loop, and it displays 4. So this is the output from the first loop is what you see right here. Loop 1, it says I loop number 1, and it displays 3, 4. Then it goes through, now that it kicks out the 3, 4, so then it's down here, and it goes back up to the top right here. Now it sets I equal to 2, display I loop 2, and then again, it comes into this loop, and it says j equals 3, and then j equals 4. And so that's what your output would there. It says I loop 1, 3, 4, I loop 2, 3, 4, just so it could do that. So you can nest your for loops. Very common to do that. The very common mistake is you make both of these i's. For I equals 1 to 2 and I equals 3 to 4, you're redefining I in the middle of a for loop, and it'll crash on you, or it won't give you what you want. So just be really careful that your inside for loop uses a different variable than the outside one. So this one used j and that one used I. If you give it I, it probably won't give you an error. It'll just give you the wrong answer. It'll be like, it'd just get confused as it went through. It might give you an error. All right. Sample codes. See, take a minute to figure these things. What is the value of series after running this code? Just give you an example of doing this. Bryce, you were winning with this last time. See if you can win this time. Yeah, just this little section here. X equals 4, n equals 3. Series equals 0 to start with. M equals 1 to n. You code it up, see what you get.
84.
You get 84?
Is what I did in my head. It might be wrong.
I know, it's too much math for me. Okay? We can do it. Let's do this together. Let's do it together. Are you coding it up there, Noah? I wanted you to think about it, but that's okay though. You code that bitch up. See what you get. Code it up and see what you get, and then we'll do it together as a group. I made this too hard. I got to write it down each time.
If you make me do something like this on the test, I'm gonna fail.
I'm good. Well, then you can write on a piece of scratch paper real quick as you went along. Without scratch paper. Did you get it, Ethan? Did you get it 84? Is that what you said?
Not yet.
Did you get 84? Kira, you agree with the 84? Did you run it?
84. I got it.
Did you run it? Did you run it? You ran it, 84. Okay, so let's do it together as we go through this thing. Okay? X equals 4, n equals 3, series starts out at being equal to 0. So it says for m equals 1 to n, do this thing. Okay, so right now m is equal to 1. So then series, the new series, is equal to 0, the old series, plus x to the m. So x is 4, m is 1, right? So 0 plus 4 to the 1th is 4. 1th? 4 to the 1th?
4 to the first.
4 to the first. Thank you. So series is equal to 4 after the first loop. Series is equal to 4 after the first loop. Okay? So then you come around. Now m is equal to 2. Okay? So then it comes in, and so m is equal to 2. Series, the new series is 4. So 4 plus x is 4, 4 to the second. 4 plus 4 to the second is
4 plus 16.
4 plus 16 is 20. So now series is equal to 20. Okay, is everybody with me here? MT, has you got this, how these for loops work? And now it's equal to 20. You guys got it? Gavin. Do you get it?
You slid it a little slow.
yeah. So you get it, right? So series equal to 20 now, right? So now series equal to 20. Goes back through the loop. M is equal to 3. Series, the new series is going to be 20 plus 4 to the third.
Which is 64. So
64, so 84. 84. But we're not done yet. Isn't that was only third? Oh, was that the fourth?
And
N
it's 3.
is 3 right now.
yeah.
Well, it's
and
1
only
to
goes
3.
up to
It
3.
goes to 3.
Oh, it only goes to 3. It only goes to 3. I was testing you. I was testing you, fuckers. Okay. There we go, 84. Everybody okay with this, right? I mean, it's you see how these things work. You know, I always find it easier to interpret the for loops when you go to make one yourself. That's where you gotta start thinking a little bit more, right? It gets a little bit difficult. Let's try this next one. What is the value of series after running this? Is it the same one? There's no line here. That's my cursor. I did a screenshot of my cursor. There's no line there. It's just a plus.
Series.
So what it does here, I guess we don't have to go through the whole thing again. But when you do it this way, it says series, the new series, is equal to a vector with the old series and this new element out front. Okay?
So it's doing a vector of the old series multiplied by.
It's just making a new vector that has my old series, and then it has my series of my mth variable plus x to the mth. Right there. And so this thing would grow because the first time through series. Let's see what this does.
Is that little bar just?
That bar is my cursor. Is my cursor. So what this would do is it would just start grow. Your vector would start growing.
So it's gonna give us the same results as last time, except for
It's gonna keep track of all the old ones. Yep. It's gonna turn into vectors. It's gonna have the 4. It's gonna have 4, 20, 84. It should have 4, 20, and 84 in a vector. Yes. Because this is this shoves it into those places. Did somebody do it really quick? Did you do it? Is that what it does? Yeah. It gives 4, 20, 0, 4, 20, it's 84. It makes a vector of 4, 20.
Yeah, that's cool.
Right? Because what this is, right, is it goes through, it takes the old series and it crams it in a vector with the new series each time. And then the next time through, series has grown to 2 elements, and so then it just gets bigger. And then the next time through, it crams the 3 element one into the bigger one. So this just some examples here. What is the value of series after writing this code? You can modify your code really quick to see what this does.
Yeah, I'm not gonna do that one.
This will do the same thing as the last one. That's my guess. Gavin, does it do the same thing as last one?
It does do the same thing as last.
Does the same thing as last one. And what it's doing this time, instead of like cramming it like this one, where you're taking the old vector and shoving the old vector into this other vector, it's saying, right, series of 2, the first one through, you cram something in. The next time through, it says series of 3, it crams the next thing in. And it goes through a series of 4, it crams the next thing in. So it's just taking that and throwing them into a vector each time.
Right, it has to be n plus 1.
Yep. Yep, that's right, because it'll grow each time. So because this just takes it and puts it in a vector as well. So okay, try this one. A factorial is the product of all the integers from 1 to integer n. For example, 5 factorial is 1 times 2 times 3 times 4 times 5. Create a for loop that when given an integer n, it calculates the factorial of that integer. Compare your answer to MATLAB's built-in function for calculating factorials. What's your example? Give that a shot. Give it a shot, big guy, Sean. Huh? I'm gonna try to do it. See if you can do it faster than Gavin. If you can't do it faster than Gavin, you're my new person I pick on. I don't know. That's a really good question.
You get used to it.
Nope.
Done.
You got it. Me too.
Oh, yeah, definitely.
How'd you do yours? There's many ways to do it.
I did 10 times the last one.
Right, works it. It always gets weird because there's so many different ways you could do it. Quit looking at mine. Jeffrey.
Back to
You get it, yes? You did get it?
No, I'm getting it.
Oh, okay.
The memo didn't get it out.
The number of different ways.
Dude, is that 52?
52 factor. All right, we'll watch that next. I don't know if did we watch that in the class before?
But
It's timely. Did you get it, guys? You do. Let me see what you did there. Oh, you do what I did. You copy what I did, dude. Does it make sense what that is?
Yeah.
Okay, no, you're copying what he did. Would he copy what I did?
Well,
And just what'd you do? Oh! What's going on over here? What did we do over here? Ethan, did you get something? Okay. Did you get Noah, huh? Did you get it to work? See, that's what I said earlier, right? I said it's one thing to like, to be able to interpret. It's another to like create, right? Ciara?
Yeah, mine's not working.
You struggle with it for a little bit.
Oh, it's just one thing.
Oh. Okay, did you get it?
No.
Too easy, you don't want to try it?
I tried it, I didn't get it.
What'd you get?
Not right. It's just coming up as one. I can't, I'm trying to think about what to add.
Oh, instead of multiplied by 1, multiply it by I. Right, because otherwise you just multiply it by 1
That's
each
what I was
time.
like,
Because you multiply by 1, that should do it.
It did it.
Yeah. Right, because
Yeah.
when you had 1,
It's
it just did the same thing over and
That's
over
what was
and
in
over.
my
and
head
over.
trying to, I was like, that's just the same.
Yeah, but then I's going to 1 to 2 to 3 to 4.
Yeah.
Yep.
Cause the F just
Okay, I got it
replaces
figured out.
the
Yep, that's right. Just replaces the equation. Did you get it? Huh?
I made a silly mistake.
You did. What did you do? What was yours?
That's
I
I was having.
I got this as 10 as well.
Yep. Yep.
So Mike, for
Yep.
the
You want the old, you want the new one in the
Okay,
next.
so that's why
Yep.
you.
the homework, what is it, like the grading scheme? You know? Okay. Can we, would it be appropriate to do one of those switch functions for that?
You do it any way you want.
So there's a lot of different ways.
Yeah, there's a lot of different ways you can do it, but I think the switch would probably be the. Yeah, I don't know. It's up to you.
I'll try
It would
it.
work either one.
Well, so-
Well, no, switch wouldn't work because if it's in like switch is it when things are very distinct values.
Okay,
If
so
it's
it's a-
1, if
it's a
it's 2,
range.
if it's 3, right? Versus
Well, can you not do if it's between 1 and 3? Can you not use inequalities inside? of the
case,
switch?
but it might you
Case.
could.
Yes,
You
you
probably
might.
case it's between 2 variables.
You might be able
Yep.
to define cases,
Yes.
except for
Yes.
you can't like for the whatever the other one's called. You, if else statements.
I'm not sure you can. You'd have to see.
Well, for the if else statements, you can put it in the if statement.
Yeah,
as
yeah,
well,
yeah.
But for the switch, it's only a variable that it's looking at.
It's only looking at one variable, and then whether or not you could put a
It's
range
one.
that variable can be within, you could try it. I'm not sure it'll do that. How are you doing? Did you get it? So no. Okay. I want you to try a little bit. Elliot, did you? Yep. Oh, it multiplies. Oh, there it is. Oh, just put a semicolon after your. Or a semicolon. And then I'll show you. Oh, but it's at the same point. Well, because yeah, because I display it each time. See, I don't put a semicolon after it, and so it just displays it. Then nothing will come out of it after this point, right? The one that's inside there, and so it actually nothing will display. You could ask for F afterwards.
Oh, interesting.
Yep, that one I just showed with 7 with 7. Right, and then you can just say what F is afterwards. And that'll just show you. So it's just inside the loop it's showing you each time, but then. But see, I think the way you have it, it doesn't need to be in the for loop. Because A is equal to just 1, and it's going to 1 to G, and then it's doing the product of all of them, and then that's it. It doesn't even need a for loop. Yeah, because you count, because the command product that you have does all of them. It does 5 times 4 times 3 times 2 times 1 anyway. Yeah. So it already does. It already does it. Yeah. Yep. Did you get it, Ethan? Okay. So when you give up there, no, did you give up there? No. Okay, keep trying. Did you guys get it?
No.
Cute. What's it doing?
It doesn't work.
You're going down here. You're going down. Make sure you use M. So what you want it to do, the way I did mine, is I factorial, right? That's your new factorial. It's going to be, and then the next time through, you want to multiply it by the next number. So if you just did factorial times n right there, just what you call factorial. Right? That should do it. Oh, but then you have to start. Where did you say factorial is? Yeah, set it to 1. And then that should do it. See, that does it. So basically what it does is it's equal to 1. And so the first time through it says m is equal to 1. Then 1 times 1 is 1. So that's 1. So that comes over and then it goes m equal to 2. So that's 1 times 2. And then 1 times 2 is 2. So then the next time through it multiplies it by 3. And then it multiplies it by 4. And then it multiplies it by 5. And that's where the 1 comes from.
I was like doing like n times like n plus 1, but then it wasn't.
Wasn't quite doing it. Yeah. Because it's just you just the way I did mine is just multiply by the last number. Yeah, and it just kind of does it as it goes along.
Okay.
Yeah. Connor. Samesies, did you get it? Does it work? It doesn't. Yeah, and then it turns out you probably would avoid the variable factorial because that's the command that MATLAB uses is factorial.
Oh, it
So
is.
if you wanted to compare it to what MATLAB command was giving it, then you couldn't do it right now because you just overwrote what factorial was. And so it uses your definition for factorial instead of MATLAB's. Yeah, instead of MATLAB's. And so you just avoid that command if you wanted to show it. Because if you did the command for in MATLAB is factorial
Do you just do
in parentheses the number you want the factorial of. Yep. You got same 120. What didn't work?
The inequalities wasn't switched on.
Or they don't.
It's like it's exactly.
Yep. That would be the case.
But it seems like it can be really useful for like this is the one that I saw most useful is you can like define a plot type, and then when switch reads that variable, you have like whatever input you
Sure.
put in, it'll generate a plot of that type. So like bar,
Sure.
or something like that. So you can use it in GUI to be like, somebody types in
Yep.
something they want.
Something that has
and
exact
you use
values.
the switch value to like pick one of those.
Sure. Yep.
Also,
But you could also do that with a if statement, right? If it equals this, if it equals this, if it equals this. But it just may be a little cleaner with the switch statement.
Also, my friend built an entire program using O3, OpenAI's O3.
He built what?
An entire program, like an entire app.
Oh, did he really?
I'll derail you on it if you.
I'd like to see it, yeah.
If you want to see it.
What kind of app? Just in Python or something, or what?
Yeah, Python.
Yeah.
He was building like a meal tracker and he was trying to like work out and stuff. So he was like, I want to log my calories and stuff. And he looked at the link. I'll show you.
I'd like to see it. It's pretty cool. It turns everybody into programmers. But I think you have to have at least the basics.
And he does.
Yeah, see, that's what I'm teaching you guys, the basics. So you give up. This table over here is giving up. You guys have it all working. Because you copied mine.
I copied his. Thank you very much. You just copied yours.
You copied mine, that's right. Did you get it? That's just why not, dude. This is your deal, huh? What I did. Because
I did too. I just kept checking details, waiting for that. Hey. I'm not driving my ass off.
Right, so that when you go through, but then also you have to start with F. F is the F equals 1 every now and then.
The only thing to see is structure is blue.
Yeah, up above it. Yeah, see F equals 1. Right, and then now you just
Students that are still like.
Maybe at that point you would be like,
Yeah, right. Because so the first time through it's equal to 1, and multiplies 1 times 2. Then it does 2 times 3. Then it
Like
does
directly.
6 times 4, and then it just keeps going like that. Yep.
He teaches 2 classes.
You don't need anything, but he's doing it.
The programming is hard. It really is. When you have, like I said, when you try to generate, it's a very simple generation statement.
No,
You're trying to like piece it together. The problem is you don't have constant energy drink and headphones. You need to have those things.
that's for.
Only in this phrase.
Yeah, that's right. That would help. That would help you some. Right. So let's take a look at mine real quick, just so you can see it. So you can move on to that.
Already done.
We can run down. What's that?
Already took a look at yours.
You did. Yeah, already did that. And then just so we can go on to a while loop, which is interesting, which is deep. Okay, so here's mine. Okay. So what I did is I started out. I'm doing the factorial of 5. So I just started out. I initialized a variable called f, and I set it equal to 1. Then I get here. I start my for loop. And I said, all right, for I equals 1 to n, right? So it's gonna count from 1 up to n, right? Which I'm taking the factorial. And I say my new f is gonna be my old f times my I, okay? And so the first time through, I is equal to 1. And so then here f is equal to 1. So my new f is gonna be 1 times 1. And so the first time through, it's gonna be 1, okay? Then I becomes 2. And so then now it goes f is equal to 1, and I take 1 times 2. My new f is going to be equal to 2. So 2 factorial is 2. Then I go, and then I becomes 3. And so now f is equal to 2. So 2 times 3 is 6. So my new x is 6. And then I go through again, and then my n is equal to 4. And so it'd be 6 times 4, which would be 24. And then it goes I equal to 5 this time, and it takes the product of the last one, which would be 24 times 5. It ends up being 120. And so that's how I did it. Many different ways to do it. That's the way I did it. It worked out pretty well. And so then I compare it to the command that MATLAB gives you. The command for factorials in MATLAB is factorial. Very clever name for the command they want. And so factorial, and you put in the value they want the factorial of, and there it is right there, 120. And so I show you each time. First time through, f is equal to 1, then it's equal to 2, then it's equal to 6, then it's equal to 24, and 120. But if you didn't want it, you would put, right? You'd put a little semicolon there so you wouldn't have to see it, okay? So 52 factorial is, we're gonna watch a little video of the 52 factorial. This gives that, it is 8.058 times 10 to the 67th. So that represents how many combinations a deck of cards can have. Have you seen this video before? Have you seen this, Noah? Okay, I'm gonna show you this video. This talks about how big of a number 8.05658 times 10 to the 67th is.
It's pretty absurd.
It is absurdly big. And it basically saying when you shuffle the deck of cards, it is almost perfectly, it's almost certain that it's never been that deck of cards ever before in the history of man ever and will ever be, which is crazy, right? That it works like that. All right, so this is the little thing.
52 cards can be arranged. There's obviously a lot. The top card could be any card, so there's 52 different possibilities. Any remaining cards can follow, so there are 51 possibilities for the next card. 50 for the third spot, 49 for the fourth, and so on. Multiplying all of these numbers together gives us how many unique ways 52 cards can be arranged. 52 factorial is a gigantic amount. So large, in fact, every time you shuffle a deck of cards well, smoosh it for a few minutes or riffle it 7 or more times, chances are you have put those playing cards into an order that they have never been in the entire history of cards, or humans, or the universe. Seriously. This is because 52 factorial is 8.0658 times 10 to the 67th. In comparison, the observable universe is only about 10 to the 18th seconds old. Even if you had been properly shuffling a deck every single second since the universe began 13.7 billion years ago, you still, to this day, wouldn't have even come close to assembling every arrangement possible. But even that doesn't paint the whole picture of just how big 52 factorial is. Scott Cheepiel wrote what, in my opinion, are some of the most mind-boggling visualizations of the size of 52 factorial. Imagine setting a timer to count down 52 factorial seconds. While the timer runs, stand on the equator and wait 1 billion years. After 1 billion years have passed, take a single step forward, and then wait another 1 billion years before taking a second step, and so on. Once you have walked all the way around the Earth, take a single drop of water out of the Pacific Ocean, that's 0.05 of a milliliter, and set it aside. Now continue walking at a rate of 1 step every 1 billion years, removing 1 drop after every journey around the entire Earth, and by the time the Pacific Ocean is completely empty, put a single sheet of paper on the ground. Refill the ocean and keep going until the stack of paper reaches the sun. At that point, how many seconds will be left on the timer? Will it be 0, a few hundred, a few billion? No, there will still be 8 times 10 to the 67 seconds left. You have barely made a dent. If you start all over again and do that whole thing 1,000 more times, you will only be 1/3 of the way done. Luckily, Scott has a great idea for how to pass the rest of the time if you're bored of paper and water and walking. Instead, he says, deal yourself 5 cards every 1 billion years. When you finally deal yourself a royal flush, buy a lottery ticket. If the ticket wins the lottery, throw a single grain of sand into the Grand Canyon. As soon as the Grand Canyon is completely full of sand, remove 1 ounce of rock. That's about 28 grams from Mount Everest. By the time Mount Everest is leveled, take a look at the clock. This is what will be left. Do the whole royal flush, lottery ticket, Grand Canyon, Mount Everest thing 256 more times, and then, and only then, will your timer have reached 0. That is how big 52 factorial is. It's pretty big. But now think about this. The number of possible people, the number of different humans there could be is, well, even larger. What that means is that even though you will probably die, most people, including possibly the smartest or funniest or most annoying possible person, won't even get to die like you do. They won't even get to be born.
In terms of combinations of DNA, right?
I'm glad you were.
They won't be
and as always, thanks for watching.
Like every possible combination of DNA. Anyways, I always found that
Stretching
that
will
whole-
not make you flexible and it will not eliminate.
the whole drop of water thing was pretty great. 1 billion years, and every time you take a step, and then still there's 10 to the 67 seconds left. It's like, what the fuck? Those are big numbers. I mean, the other one, like you may have heard too, but like how long, like you could count to 1 million in like 3 days or something like that, but to count to 1 billion, it's 32 years. Like, have you heard of this before? So there's a big difference between 1 million and 1 billion, right? When somebody says they're a millionaire, like I've determined last night I'm a millionaire. If you count my retirement and my house, I'm a millionaire, right? Versus somebody that's a billionaire, right? That takes you 32 years every second. If you count one value every second, it takes you 32 years to count to 1 billion. So a billionaire is way too rich. There shouldn't be billionaires in the world. There should not be billionaires in the world. I'll go ahead and say that.
It takes more than 3 days to get this.
Figure it out. Create a function that calculates. All right. Okay. While loops. Okay. So while loop, like a for loop, I would say 99% of my coding I'll do with for loops, because for loops are just set, right? I want to run through something 4 times. I = 1 to 4. I run 5. I = 1 to 5. Right? Like it really just runs at a certain number of time. A while loop will continue to run until something happens. Okay? But this first thing that you say. So this says while the value I is less than 4, you do this stuff in the middle, but you do it until I does not become less than 4 anymore. Right? These are dangerous because they can create these things called infinite loops. Okay, so there's one up here, this while loop up right here says I = 1. So it comes down and just says, all right, is I less than 4? I is equal to 1, so 1 is less than 4. So then it comes down and it sets the new I. The new I is going to be the old I plus 1. So it's I = 1, now I = 2. So the next time through the loop, it comes up and checks, is my new I 2 less than 4? Yes, it is. So then it keeps going. So now it says, well, I'm going to make a new I. It's the 2 plus 1. That's going to be 3. And so my new I is 3, and is 3 less than 4? Yep. And so since the 3 is less than 4, it runs it again. It says, right, my new I is my old I, 3 plus 1. It's going to be 4. So my new I is 4. Is 4 less than 4? No. So then it stops. It kicks you out. It just says, yep, that doesn't happen anymore, and it ends. So in this case, when I ran it, I started out, it became 2, then it became 3, then it became 4, and then it kicked you out. And so at the end of running this while loop, it ends up being 4. This guy right here, though, is an infinite loop. If you put this into your, go ahead and do it if you want. Put this into your MATLAB and say run, and it'll just say busy, and then it will never stop, right? Because this one goes like this, right? I is equal to 1. Is I less than 4? Sure is. Then it doesn't do anything with I. It just shows I. And so then it goes, I is equal to 1. Is I less than 4? Nope. Is I less than 4? Nope. Is 1 less than 4? Nope. Is it less than 4? Nope. 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 Or it is less than 4.
Yes.
Sorry, other way around. yeah. I is 1. Oh, it'll keep going. Sorry, it'll keep going. I is equal to 1 is less than 4. Yes. So then it does it again. Then it says it's 1 less than 4. Yes. Run again. 1 is less than 4. Yes. Run again. 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 Go ahead and do it. Give it a shot. It'll create an infinite loop. This is where that Control C will come in handy. If you accidentally create an infinite loop, you hit Control C and it'll kick it out. Okay. And so you could add in a break too, right? So this one right here, I just added in a little thing to stop it, right? As I is less than 10, this loop will keep running and running since I don't increment I in this thing. And so it displays I, and then it keeps track of a counter though. What I do is I start out with a counter equal to 0, and then I increment the counter each time, but I put in this other thing. If my counter ever becomes greater than 15, then break. This little command right here means break out of the while loop, and this would kick it out. And so this thing would start going, this upper part would just start displaying 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 over and over. But then I've got this counter that starts out at 0, and then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then when it becomes 16, it says 16 greater than 15. It is break, and it kicks you out of the while loop. So it's just adding this little thing right here, just in case you end up with some sort of infinite loop, it'll kick you out. Okay? Do the same thing now that you did last time. You create a factorial, same factorial, but do it with a while loop instead of a for loop. Give that a go. Yeah.
You put like a I if I is greater
Yep.
is less than 10 if
Yep. Yep. You can put in whatever, like the little operators in between, and or ors or exclusive ors and stuff like that. You can put it in there. Yep.
Take 11 days.
11 days. 11 days to count to a million. Versus 32 years to count to a trillion.
Still a big difference.
Big difference. Big difference. But not as exaggerated as I.
That's okay. That's okay.
Did you get a haircut, Bryce? Yeah, looks good.
Yeah, it probably doesn't look good right now because
That
I'm
looks
wearing a
great.
hat all day.
Looks great.
Thanks, Chief. Appreciate it. I have a question.
Yes, big guy.
Am I allowed to use the factorial function? in finding the factorial.
Well, you don't need a while loop then, right?
While fac f is less than factorial.
Yeah. There you got it. Yep.
No?
No, you don't need that.
You sure?
Yeah.
Okay.
Yeah, you said well n is greater than 0. And n is going to be greater than 0.
All right, I got mine to work. I do a little editing too. I couldn't get it to work. Did you get it to work?
Use your code first.
Yes, I got it. Let me see yours and check it and see if it's okay. Yeah. Good point, Gavin. Good point. You can use your other code. It's just turn it from for loop to a while loop to see if you can make that work. Oh, we're missing two here. We're missing Joseph and
Marissa.
Marissa.
Yeah. I don't know where they are.
Waiting for them.
Yeah. Oh. Yep. So yeah. So what you is that stuff in that slot?
No.
Like save that slot keeps up previously. It just keeps in track of the order in which you plot. So my guess is you plotted something and it still exists on there. You just can't see it. There's stuff on top of it you can't see anymore. So what I would do is right before this, you call out the speaker and plot on it, clear that figure. If you clear it, then that should do it. You just put wherever you call out like figure 1. Right, perfect.
200. Which it's a big
makes sense.
Then you plot, and so it basically goes in that order. You plot that, then you plot, then you plot, and so it should come into that order. If you put the CLF in there, that should do it.
They're gonna initialize.
So first thing you plot is this. And then gets that one. And then the next thing you plot.
Break.
That's the problem I have, that's the average. I got the right answer.
I got a number bigger than 52 Victoria.
Yep, and then the third thing you plot is this.
Said X is 1 and is 5. I change it. And I said, well, X is less than X, or 5, but X is equal to this. Look at my next step. I tried, there's some, well, Y is less than that.
No, you're right though, but it should. Like you said though, you put this here.
Well, I is less than 3.
It's an undesirable empty double. What the fuck?
That's also wrong.
I know.
Yeah, because there's something going on, because the red line that you have is actually, is this last one. The fourth thing, and I mean, it's going in order. Yep, there's something else you're plotting that we can't see right now. Yep. That's all. It's just off the top. So that'll do it, but you gotta do something where, well, see what happens is your eye never changes. Yep, it's just one by one, and then you go in. Yeah, so then what you need to do is just make I get bigger at the same time. So after this command right here, just put I is equal to I plus 1. Like, you know, on the next line. Right, so now it'll grow. So that should be. Right, because then, so then it starts out with I equals 1. Maybe it said I equals 1 to start with. Yeah, up above where F equals 1. So, no, you leave the I is equal to I plus 1, but just outside the while loop. No, because all you're changing is I. F is growing like it's supposed to. Yeah, just try that. But then outside the while loop, you have to I equal. Outside. Yeah, otherwise it'll and otherwise it'll make it 1 every time. That's what happens.
Second, let me see this first.
I could have backed for it. I don't know.
Get it? Either word?
Yeah, I'm plotting it. It's very difficult.
You want to plot for it, Jason? It's going. Yeah.
Oh,
There it is. But then F is equal to 1, I is equal to 1. replace the old f. You have to get bigger each time. Get it? No, you got it? You guys get it?
No.
You got infinite loops?
Yeah.
I got infinite loops.
Lots of infinite loops going on. Did you get it? Hells yeah.
I'm really-
Increment your eye, right?
I'm really close, but I'm a little off.
Yep, that's right. You incremented your eye, right?
Yeah.
M is equal to M plus 1. Otherwise, it'll keep going forever. But you made the M get bigger each time. Perfect. Yeah. Ciara wins. Ciara wins. Nothing?
I got it.
You got it.
So, anyone
I
else
was
have
trying to
any
do
idea?
like a vector.
Yeah.
Just like making a vector. And
Yep. You got it. Kaylee, you get it?
I am
You don't get it.
close.
You're not allowed.
I don't know. I was getting an infinite loop, so I did something here. I got something.
Yeah, that's right.
But what's going on? Why is it showing me?
Oh, because you have less than or equal to n. If you just make it less than n, it'll cut
Oh.
it'll cut off.
Yeah. You got it. Hells yeah. You get it? Good. Good color. Good color. Yeah, okay.
Yep, so that's it. But the one thing you have to do, because this will go forever. Okay. Right? This will go forever because your I is just always going to be equal to. You start out with I. Oh, you said I equal 1.
Yeah.
Just set I equal to. It can't handle it if it's like a vector like this. So just set I equal to 1. And then inside the for loop, you want I to get bigger each time because at some point you want it to kick it out. So what you do here is you just do, I is equal to I plus 1. Well, do a new line.
Oh, okay.
On a new line, just say I is equal to I plus 1. Right? So then that way, each time it runs that while loop, I gets bigger each time.
Okay.
Right? And then at some point, this won't be true anymore, and it'll kick it out. And that should do it. Yep. And onions.
Onions for lunch. I apologize to everybody in advance that.
That sandwich was good.
It was a great sandwiches, yeah. Yeah, you're welcome. You owe me lunch. So Kyle, right there, that's
I'll
a-
take 15 minutes off.
yeah. So that's an infinite loop.
No, it's not, because I don't have will written anywhere.
Oh yeah. Okay. If you turn that to a while loop, that would be an infinite loop,
Yeah.
right? Because you have to make sure that something gets big enough for that statement to not be true. Down m equal to 1 to n, say m is less than n. You want to run it until m is less than n, right? And so if you ran this